All right, for this lesson, we're on lesson 8.2, applications of area. Now, for this one, I've only given you about 5 problems to go through. Do the best you can on these, okay? I know word problems, application problems are things we tend to not like to do, okay? But I'm only giving you 5 of these. Slow down, break the problem down, draw pictures on them. Do the best you can to understand the problem, because this is the type of math where you can actually tell if you're using your skills to solve real world applications, essentially real world problems. So I'm just going to go through a couple here. I'm going to focus most of my time on number 1 to show you how I break this problem down. I may talk about number 2 a little bit. Number 2 is pretty simple, but then I'm going to finish off on number 4 at the end here. And we'll leave this lesson that. So it's a little bit shorter lesson, hopefully. All right, so on number 1, they give me this diagram. Now, this is a typical type of problem that you might encounter. It says a bundle of hardwood flooring contains 4.5 square feet, or 14.5 square feet, excuse me, and costs $39.90. And so they give me this diagram of your kitchen, family room. They have like a tiled area here. It says how many square feet of flooring is needed to cover the kitchen and the family room, exclude the fireplace hearth, and the tiled area. All right, so let's go ahead and get started on this one. So what I'm going to do is I'm going to find the area of, let's start up here first. I'm going to find the area of this whole big rectangle. So this length here is 16, 13 plus 3, so 16. This length all across here is 24, 18, and 6. And so that is going to be a total area, the kitchen and the tile, it's going to be a total area of 16 times 24. So that's a 384 area for that, okay? So let's go ahead and let's write that number down. We'll keep track of our numbers here. All right, so my kitchen is, what was it, 384 so far. That's everything. But I am going to subtract the area of the tiled section. So that is, it's also a rectangle. So 3 times 18. So 3 times 18 gives me 54. So I'm going to subtract 54 from that. And that gives me 330 square feet. Okay, so that right there is my kitchen area. Now we have the family room, and so I'm going to do the same thing. I'm going to find the area of the overall rectangle here, then I'm going to subtract out these 2 pieces here. So the whole big rectangle is 18 by 14, so this is my family room. And you'll notice I'm trying to just keep my information organized. So my family room is 14 by 18, so 14 times 18 is 252. Now, I want to subtract both of these out. This one's pretty easy, the hearth here, because that is just a square, 4 and 4. So that's an area of 16. So I'm going to subtract 16. This shape is a trapezoid. Now, if you remember our trapezoid formula, so for this one, I'm going to go ahead and just write it down here. For the trapezoid, the area of a trapezoid, this base here, the bases are the parallel sides, so this base here is 7, this base here is 4, and then we're going to multiply that by the height. Now the height is this 3 feet here. That's the distance between the bases. So times 3, that whole thing divided by 2. That's the area of this trapezoid shape. All right, so let's calculate that. So 7 plus 4 times 3, all of that divided by 2. That's 16.5. So we're going to subtract that as well from that total area. So that's going to give me 252 minus 16 minus 16.5. So that gives me 219.5. So that is the area of the family room that I want covered in this flooring. Let's go ahead and add those together, and we're going to get the total area. that I want covered. So that's going to be 330 plus 219.5. All right, that gives me 549.5. And that is in feet squared. So that is, that's my answer to this one. So part A, 549.5 feet squared. So that is the answer to part A. All right, so not too bad, just basically a couple rectangles, and then we had this trapezoid. That was the only kind of weird shape, and there was this trapezoid. Everything else was pretty basic, just rectangles, and then we had a square. All right, so fairly simple there. Let's go ahead and look at part B. You should buy 5% extra flooring to account for waste. So that's true. You're going to have to make cuts to the flooring. You have to go around corners and weird things. So you probably should buy some extra. So we want 5% extra flooring to account for waste. All right, how many bundles of flooring should you buy? Okay, well, if my area covered is this, I want 5% more of that. So how do I calculate that? Well, 5% is 0.05. So I'm going to take my 549.5 and I'm going to multiply that times 1.05. Now, why am I multiplying it times 1.05? Well, because 0.05 is 5%, but the 1 accounts for keeping what I already have, right? So I'm going to take 1, which is that, and I'm going to add this whole 49. 0.5 times 1.05, excuse me, and we multiply that out and we get this number, 576.975. So 576.975, is that right? Yes, it is. So that's how much flooring I'm going to want. That's going to be 5% more than the exact amount. All right, but then they say, how many bundles should you buy? Okay, up here it says that a bundle contains 14.5 feet squared, and then they tell me the cost. So that's how much is a bundle. So if I want to know how many bundles I should get, well, I'm going to divide 14.5 into the total amount. Okay, I'm going to divide that into that. So let's take this number. So 576.975. I'm going to divide that by 14.5, so 14.5. Divide. These are the same units. These are all in feet squared. So I'm going to divide that into it, and it's going to give me the total number of bundles, which is 39.79. Now, you can't buy part of a bundle, right? So I can't go buy 39 bundles and then, like, take pieces of other wood, right? So I have to round this up. I'm going to have to buy 40 bundles. Okay, so 40 bundles. I'm kind of stuck buying 40. What will that cost? Well, the cost for a bundle is $39.90. So let's calculate this. 40 bundles times $39.90 is $1,596. So bundles and then the cost. That's a 1,000 there. $596. Okay? All right, so that's that first one there. Let's go ahead and look at number 2. I'm not going to go through and do all of number 2. I just want to kind of show you how it'd be done. On this one, it's just a bunch of rectangles. So you have this cake, and it's a rectangular sheet cake. So it has the top, and then it has 4 sides around it. All right? And they give you the dimensions of all of those. Essentially, what you would want to do on something like this is you would want to find the area of each piece. So you have a total of 5 pieces. You have 4 sides around the cake and then the top of the cake. So you have a total of 5 rectangles. And you want to find the area of all those, add them up, and that's going to calculate your total area. It says here that Bert wants to apply frosting to the 4 sides and the top, so all 5 rectangles. How many liters of frosting does he need if 1 liter covers this? So you'd find your total area, and you divide it by 1,200. That would give you how many liters. And again, with that one, assuming you can't buy parts of a liter, you'd have to round that one up as well. All right, but let's go ahead. I'm going to just finish up looking at number 4. Number 4 sounds complicated, but it's real simple. All right, let's look at it. Kit and Kat are building a kite for the Big Kite Festival. Kit has already cut his sticks for the diagonal, so he's already cut the sticks. He wants to position P, so this point, so I guess you can move this stick up and down, so that he will have maximum area. He asked Kat for advice. What should Kat tell him? Well, when you look at this one, you think, well, if I move this diagonal up and down, maybe that will adjust the area. But what do we know about the kite's area formula? It's diagonal 1 times diagonal 2 divided by 2. And so once you have the diagonal lengths already in place, it doesn't matter where you would position this diagonal along the first one. The area won't change because the area is dependent on the diagonal length. So Kat should essentially tell him that once you cut your diagonals, the area is going to be constant. The area won't change at that point. All right, I'm going to leave our lesson there, and I'm going to let you guys work on those application problems for 8.2.